On June 1st, 2016, UCLA became the site of the most recent school shooting. The case was designated a murder-suicide as Professor William Klug was fatally shot before the shooter took his own life. This video is dedicated to Professor Klug, his family, and his loved ones. During the nearly 3 hours of campus-wide lockdown, social media became super saturated with people posting statuses saying "I'm okay" and contacted loved ones. But as we now know, there was also a great deal of misinformation spreading on social media that day. The following are actual messages that I personally received that day, many of which we now know to be false for various reasons. The key question is then, what happened? How did this misinformation come about, and what can we do in the future to help prevent this? To begin answering that question, we're going to look at two key factors: information and people. In this video, we'll be treating information as packets. Each packet has an associated truth value. This truth value ranges from 0 to 1. A truth value of 1 means that the packet is absolutely, irrefutably correct. We can go lower. We can say a truth value of 0.9 says that packet is 90% true. Going even lower, we get into dangerous territories, such as 0.3, saying that the information contained in this packet is only 30% correct. When a person receives a packet with a truth value of 1, due to certain biases and fluctuations within the individual, they're going to pass it on, and some information will be lost. It'll be diminished from 1 to a lower value. So let's just call it P. Let's fix P here to be 0.9. But of course, they're not doing this with every single packet of information. This is just a mean value. Sometimes it'll be something like 0.88. Sometimes it'll be higher, like 0.93. Sigma will signify our volatility of the truth value conveyed by this person. Let's fix it at 0.02 for now. What happens when a crisis hits? Our volatility goes from 0.02 to 0.1. When you think about times of crises, people's propensity for understanding the truth does become a lot more volatile. Now we're going to see what happens to a piece of completely correct information as it passes from one person to the next. We take this completely correct piece of information and pass it to the first person. Now this person, we're going to assume, like before, has a p-value of 0.9 and a volatility of 0.1. How much of this information will this person convey correctly to the next person? To answer this question, we're going to be using something called a confidence interval. It's an interval built off of our p and sigma values that tells us with 95% confidence what's the value this person will pass on to the next person. When we do our calculation, we find that our 95% confidence interval is 0.71. We're 95% sure that the truth value of the information passed on lies between 0.7 and 1. We're going to pick a number in that range. We're going to pick 0.8 and say that this person passes on a piece of information with truth value of 0.8. Continuing this process, we can say that for this last person, we can be 95% sure that the truth value of the information that they're going to convey is within about 39% to 79%. We went from a completely correct statement to a statement that's between 39% and 79% correct. That's a huge drop in confidence. If we plot this on a number line, we find that within these red windows is where our confidence interval is. The point is, we're just really not sure how much value to place on this final person's statement. It could be 39% correct, it could be 79% correct. Now, what we really want to do is compare this against the case when there's not a crisis. Remember, this is the case when our p-value, of course, is still 0.9, but our volatility has gone down to the regular 0.02 value. If we repeat all the same calculations, go through the same 3 people, we find that our final confidence interval is 67% to 75%. So just to recap what's going on here, we found these two different confidence intervals. And the first thing to note really is just what's the difference between the upper and lower limits. We find in the crisis case, the difference is 0.4 or 40%. In the non-crisis case, it's only 8%. Looking again on the number line, if we want to see this graphically, we see in the blue windows here, this really tight blue range tells us how confident we are about the final truth value after all 3 people have seen and passed on this statement. Now, this much bigger red window tells us how confident we are in the crisis case. We can see that we, of course, really like the non-crisis case and really don't like the crisis case in terms of trusting the information that we're getting. The key thing to keep in mind is keep your sigma low. If that sounds kind of weird, it's just the same thing as saying keep a calm head or keep a rational mindset. In essence, just keep smart. It definitely will be a while until many of us feel safe again on campus. But we will persevere because we are Bruin strong.